All right, the last section for this unit deals with how we raise a complex number to a given power, whether that be a positive number, positive integer, or whether it's a square root, cube root, or whatnot. So de Moivre's theorem is up on the screen there. If we have a complex number in trigonometric form, so this is our trigonometric form, and we raise it to some positive integer n, some power, then, well, clearly we have a product of two things. One of them is r, and the other is the cosine theta plus I sine of theta. So we raise each of those to the nth power. Well, r to the n is just r to the n. But the other thing, cosine of theta plus I sine of theta raised to the n power, we get to just basically drop the n into the function, which is amazing. So many times I've seen students try to do things like this in algebra where it just doesn't work. Here, you just get to drop it in. And if you want to see how it works, on page 342 in your book, right above this theorem that I have up here, they go into why it works. But all you have to know is it drops right in. So I'll do a couple problems where we do this in your homework, and then I'll do one which is a little bit more complex where we want it in standard form. All right, so on page 346, let's do number 8. So they give us this. So this is a number in trigonometric form in the brackets there, and they're raising it to the 8th power. Okay, so we can solve for this without having to do much work. So we're going to take this. This is going to equal 2 to the 8th power. And then this is multiplied by cosine of, well, 8 pi over 2. And I wrote an 8. So 8 pi over 2, which it's 4 pi, but that's okay. Same, 8 pi over 2. So the 8 just gets dropped in to these two spots, and as well as the exponent here. So that's what we're doing. We're going to do the same thing when we do a square root in the next video. All right, so this is what we have, but we still need to solve it. Let's, I think the instructions say put it in standard form, so let's put it in standard form. First of all, 2 to the 8th is 256. And this is 4 pi, so cosine at 4 pi is the same as it is 2 pi, same as it is at 1, which is just, or excuse me, 0, which is just 1. And this is I sine of 0, essentially, which is just 0. And 0i, we don't need to deal with the I, so it's just 256. And that's all. That was pretty easy. We took a complex number and raised it to the 8th power, and we were able to figure out what it was with relative ease. Now, if you don't have something as nice as cosine of 0 and sine of 0, you may have to use a calculator or something like that. Or if it ends up as a pi by 6 or pi by 3 or something like that, just use your unit circle. All right, so let's do another one from that same group. Let's do number 15. So They're giving us 2 here each time, which is pretty easy to manage. This time, instead of pi by 2, it's pi by 10. And this time, instead of 8, is number 5. So this is the problem from the book. Well, again, we're just going to drop the 5 in all 3 spots. This one goes in as an exponent. So this equals 2 to the 5th power, cosine of 5 pi by 10, plus I sine of 5 pi by 10. Well, to the 5th is 32. And this is cosine of pi by 2. And cosine of pi by 2 is going to be 0. And sine of pi by 2 is positive 1. So this is just I. So it's 32i. All right, so again, these are some of the preliminary questions that they have. Now, they gave us problems after that where they gave it to us in standard form, and to use Moivre's theorem, we have to convert it to trigonometric form, do the operation, and then essentially convert it back. So let's do one of those. Let's do number 19. And number 19 is actually one we've dealt with before. Not the 5 part, not the 5th power, but 1 plus I we've done. So quick little sketch. Your point's going to be here. So 1 on the reals and 1 on the imaginaries. Okay, and that is a 45-degree angle. So this is theta is pi by 4. And again, I did this as an example on a previous video. And we're looking at, well, at pi by 4, it's going to be root 2 over 2. But specifically, we have r equals square root of 1 squared plus 1 squared. So r equals root 2. So this equals root 2, right? So we have root 2, and then our cosine and sine, I sine are going to be pi by 4. And that's all to the 5th power. So as before, we're going to drop the 5th power down, multiply here, and raise to the exponent here. So that is going to be root 2 to the 5th. We've got cosine 5 pi by 4 plus I sine of 5 pi by 4. All right, so not as easy as a 0 or a pi by 2, something we're going to have to look up. But, if we look at it, 5 pi by 4 is over pi, so it's going to be in our quadrant 3. And in quadrant 3, both the sine and cosine are negative. So both sine and cosine are less than 0. So root 2 squared is 2. We've got 2 of those, so that's 4. So this is going to be 4 root 2 on the outside. And again, pi by 4 is going to be root 2 over 2. So these are each negative root 2 over 2. Okay, so now we can distribute the 4 root 2. Let me scroll down a little bit. All right, so the root 2 multiplied by the root 2 gives us 2, which cancels out 2 below. So we're looking at 4 or -4 because we have the negative we're multiplying it by. And then another negative, so minus 4i. So that is I plus 1 to the 5th power. And this is the general process form. Again, number 19 was a little bit more involved, but not too terrible. And I'll show you the square root in the next video.